This is an overview of the river corn project, something that you will work on in order to improve your understanding of how sampling works and why we use different methods of sampling. Okay, so this project is just a metaphor for many applications of sampling in the real world. You may never have to do what we're going to do in this project, but you might have to do something similar. It could be like sampling people for a political poll, or tagging fish in a lake, or migrating birds or sharks if you become a marine biologist. There is a Participati video where they actually use sampling in order to do quality control for a company that makes potato chips. In general, from my experience, too many adults do not believe the results of surveys or polls because they don't understand how sampling is done. Our intuition questions the results when participants are chosen at random. Humans just are not good at understanding randomness, and we find it difficult to believe that you actually can choose participants at random. Anyways, when people hear the results of scientific studies or surveys, a lot of times they ask the question, if they're supposedly using randomness, well, what if they accidentally chose mostly Democrats when they were asking whether the president was doing a good job? Or what if they accidentally chose mostly Republicans? And the same question is asked over and over again for all kinds of studies and surveys. If we are doing a test of some new medicine or some new drug, what if the people that we just happen to choose are the ones that recover quickly from a particular illness, regardless of whether they're given a drug at all? Well, it turns out that those are reasonable questions, but the truth of the matter is that if we use a truly random process for selecting our participants, we actually avoid those issues. And it does, and you can't just do any old sampling. It does depend on whether a scientific sampling method was used. Okay, now in this project, it's going to require some teamwork. There's a lot of things that need to be done, so I'm hoping that you folks will divide the work up so that everybody has something to do. For example, each team member should do one sampling method, and there are 4 of them. Well, there's 5 sampling methods, but one of them you don't have to do anything. It's called the convenience sample. How convenient, huh? Okay, let's see here. You should have one member of the group who can be the owner of the shared project document. And what does the shared project document look like? It looks like this. It is a spreadsheet, a Google Sheet, where you have you'll use these things. You'll see there's some instruction on that, and there's one for simple random sample, one for vertical stratified, one for horizontal stratified, and one for human chooses. You'll learn about that as you read through the project document. Now, this document, one person will copy and take ownership of, and you can copy it from the Canvas project or from this presentation. Anyways, one person will have a copy of this, but they will then share this with the other team members, and each of you will do one form of sampling. And then all of you will go back through and double check that you agree. And in fact, you are more than welcome to discuss the method of sampling prior to any member starting. Okay, so let's continue on. Okay, so one team member, later on in the project, there will be more work to do. Somebody's going to have to compute the average yield of corn from the field. And somebody will have to compute the total actual yield for the entire field. That is also known as a census, and that is part of our study in sampling. That is like a sampling where you look at everybody. Okay, scientific sampling. So hopefully in this class we've already discussed sampling methods. Well, first of all, randomness is required for scientific sampling. Scientific sampling methods include simple random sampling, stratified sampling, cluster sampling, multi-stage sampling, that's a typo, systematic sampling. And then we also hopefully have already discussed some bad methods of sampling like convenience and voluntary. Now, you don't need to take my word for it that some of these methods are better than the others and some are worse than the others. That's what this project is all about, for you to get a feel for it. Okay, so sampling methods for this project, we'll look at convenience, simple SRS, stratified, two kinds, vertical and horizontal. Both are stratified, but in this particular case, we may discover that there's a reason why one might have a different result than the other. Okay, then human chooses. That is where some team member simply chooses some plots to sample, plots of corn in a cornfield. And that requires no scientific method at all. So again, I'm kind of curious to see what the result is there. So the farm itself, what is the project? River corn, what is it all about? Well, there's a farm. The farmer has a field of corn. On the west side of the field is a farmhouse, and on the east side is a river. The cornfield can be divided up into 100 small square plots. The farmer needs you, the statistician, to help her predict how many bushels of corn the whole field will yield. The farmer is not sure that harvesting the field is worth the expense. That is why you are going to do some sampling. You, the statistician, will gather data from 10 sample plots and then predict the yield of the cornfield using several different sampling methods. In the real world, you would never use several sampling methods. Well, there are occasions where you might, okay? But in general, we don't do multiple samples in the real world. In general, we do a sample to avoid having to count a million things. We want one small sample to make inferences about the larger population. So, why are we doing this? Because this is how we learn about sampling. Okay, the process itself. For scientific random sampling, you must not be able to see any of your participants or subjects when you choose them. So what we're going to do is let the computer do the work, and that's going to remove any bias that you might have. So you will first look at the document that looks like this, and this is where you will select all your plots over on the left here, and on the right is when after you're done with all the randomly choosing of plots, after you've done it blindly, then you will get from me the data that shows what the yield is for the entire field. And from that, we will take your sample X's and we will use them to make predictions, to do some math. So after you've generated your random plot selections, me, the teacher, will give you the chart with the actual yield of every plot in the field. Again, this never happens in the real world. You never do a sample when you already know what the answer is for the whole population. We're doing to learn something. Here we go. So what does the situation look like? Well, here's what the situation looks like. Let me see if I can get myself out of the way here. Here's the visual. There's a farmhouse on the left. This grid or table represents 100 plots in the cornfield, and each plot will yield a certain number of bushels of corn. And over on the right side of the field is a river, and north is up. Okay, let's continue on. Let's see. You will generate random numbers to mark which plots of corn you'll use in your sample, and you'll use an X to mark which sample plots you use. And I have already made for you some tables that you can fill in so that you don't have to do much by hand. You'll be generating random numbers and putting X's in the appropriate slots, and you and your team members will each be doing this. Okay, so let's go on to the next. So the one kind of sampling that you're going to look at the results of is called the convenience sample. Now, it's so convenient that you don't have to do any work at all because you don't have to generate random numbers. We're going to assume the convenience sample are the 10 closest plots to the farmhouse. That would be the least amount of work. Will it produce the best result? We shall see. Then you're going to try a simple random sample. Use as described in the textbook, and I also have some instructions here, and I believe there are also some instructions in the document that you are linked to in Canvas. There's some instructions here as well. Anyways, oops, what am I doing? I got to go back. Oh, I went back. Okay, here we go. So that's one type of sampling you'll do, is simple random sampling. When you do simple random samples, you can generate a number from between 0 and 99, and you can label this table in such a way that those numbers, you'll know where to put those numbers. You'll know where to put the X. Okay, next. You're also going to do something called vertical stratified sampling. In this case, you're going to divide the cornfield up into vertical columns, and you will select one plot from each of the vertical columns using the instructions here or in the other document, the PDF. You're also going to try horizontal stratified sampling, and in this case what you'll do is you'll divide the cornfield up into rows, horizontal rows, and in each row you will select one plot randomly, and then you will go ahead and put your X in the given row in the appropriate sheet. And finally, the easiest one is you're just going to put an X in 10 boxes. Make sure you count correctly, and for the human chooses, you'll just attempt to use your own human randomness to choose 10 plots. Okay, so what else? Let's see if there's anything else that I can tell you. Oh, after you're done, it says you should now have 3 grids. You'll have 4 grids you're going to be looking at, and each one of them should have 10 X's. And for, let's see here. You know what? There's a couple corrections I need to make here. Well, I'm about to tell you that when you do this project, you should verify your work, and maybe I should have taken my own advice. It would have been nice if I would have verified my slide before I showed it to you. Anyways, I reflected, I'm making the correction, and that's what I want you to do when you make a mistake. I'm trying to model good problem solving. Okay, so you should now have 4 grids that you made. Each one should have 10 X's, so you'll have the one for SRS, one for vertical, one for horizontal, one for human chooses. And when I say 4 grids, what I mean is at this point, after you, wait, let me see where we're at. You just have the X's. Okay, so yes, you will have this grid filled with X's, this grid with 10 X's, this grid, and this grid. And then, for method B, there should only be 1 X in each vertical column. Make sure you follow that rule. For method C, only 1 X in each horizontal row. So this is something that if you're the one who did the work, so one other team member should verify your work using this slide. Okay, and after you've verified that these things have been done correctly, you can let me know and I'll give you the data for the corn yields. And then you can proceed to answer the next set of questions. I keep telling you folks that for those of you that are going to take the SAT, I'm going to show you neat things you can do with your graphing calculator. I have some information on how to generate random numbers using a TI or a Casio calculator. I'm not going to stay on the screen very long though, because since we're doing remote learning and not all of you have graphing calculators, we're going to go to a website called random.org. And there you're going to use their true random number generator to generate the random numbers as necessary. For some of the sampling, you'll go a number from 0 to 9, and then you can generate that over and over again for as many times as you need to. And for simple random sampling, you're going to need to go between 0 and 99, and you can do this 10 times for your simple random sampling. Of course, you're still going to have to label the grids appropriately in order to make sure. Well, it looks like I did some of the I did the labeling for you. Okay, cool. And human chooses you don't need the labeling, so you're going to be in good shape. The labeling's done. All you got to do is go to random.org, generate the random numbers, and pop them in. Okay, I think that's it. I think that's all that I had to say. Good luck, and I hope you have some fun with this.